Hey guys, welcome. Yeah, so we had our basic practice with 4 examples, and so then time to have harder practice. Yeah, and now if you are in advanced calculus, even if it's advanced calculus 1 or accelerated calc 1 or whatever they call it at your school, then once you've watched my basic practice video or you've had that level of training, then this is definitely the appropriate level of challenge you should look for as your next 4 examples or something similar to this. Anyway, with that said, because I talked at length about the basics and the basic practice video, I'm not going to repeat myself. So anything I said there, well, you should watch that video to learn, and I'll link that video below this. But yeah, from what we said there, we've got the sum and difference rule for antiderivatives. So using that and the constant rule, I could write 2 times antiderivative, and then it's cosec x. So I'm going to go through this practice set quicker. And to start, we don't even have a discussion. We just jump right into the practice, right? And also in the basic practice video, I said that this dx at the end is multiplying everything in front of it. So we have to write a dx. Yeah, I know. I said that I wasn't going to repeat myself, but some details are worth mentioning again, especially since I know that not everyone is committed to watching that first basic practice video. Now, yes, I could write in this part plus, and then just write this whole thing as this quotient as my second integral or my second antiderivative I have to find. But I'm gonna actually split it into more. So we know that instead of this here, we could write this divided by that minus, and then it would be this divided by that plus this divided by that, and then plus this divided by that. I know I shouldn't have to explain that, but I will just in case folks needed it. Yeah, as some people say, the hardest part of doing calculus is actually the algebra. So integral, and then it's 3x squared over x, and then dx, right? And then plus, and then integral, well, it's not plus, it's minus the next guy, right? That's a minus, so minus, and then it's integral of root x over x times dx, and then it's plus integral of 2x, and yes, I could take out the 2, and then it's x over x dx, right? And we're on to that. And then finally, Jesus, I thought I had enough space. Apparently not. And then we have what left? We have to write plus integral 1 over x dx, and we know this from our first practice problem in the basic practice video. But yeah, okay, so now here in this first guy, cosecant cotax, this here, we almost recognize as the derivative of something, and it's negative cosecant cotax that we recognize as the derivative of cosecant x, right? The derivative of cosecant x is negative cosecant cotangent. So the only thing we're missing here is the negative to claim this here as the antiderivative. Well, this, in order for us to claim this antiderivative as something we know, we just need a minus sign right there. And if we had a minus sign right there, we'd say that what I circled here is equal to cosecant x, because the derivative of cosecant x is negative cosecant cotax. And so I need that minus sign right there in order for me to claim that. So I'm going to throw that minus sign right there, but make up for it, because it wasn't there, make up for it by putting a negative in front of the 2. So now I see that I have negative 2 times cosec x, because the derivative of cosec x is negative cosecant cotant. So negative 2 times cosec x. And yes, I can write plus c, but I'm not going to just yet. I'm going to combine all the c's from all of the antiderivatives into one c. Said that a lot, the first integral, so no. So in this part, right, what do we do? So we could first do this, and we just have an x in the numerator, and then we've got the 3 as a constant, which I could have taken out in front of the integral from the get-go. I just didn't want to confuse some of y'all. So for some of y'all, maybe it's nice that I waited. So yeah, 3 comes out here, and then we have just x dx, right? Okay, and then it's minus, and then root x is x to the 1/2, right? and then x in the denominator is x to the first. So exponent rules say this is x to the 1/2 minus 1, so x to the negative 1/2, right? So I could just write x to the negative 1/2, so x to the negative 1/2 dx, and we dealt with this, right, in the basic practice video. But yeah, like I'm saying, this here just simplifies to that there, yeah, and that's appropriate. And then we've got plus 2 times, and then it's just integral dx, right? Because x divided by x is nada, or well, it's 1, it's not nothing. And then the last guy, the antiderivative of 1 over x dx, we know is the natural log of x, so we could say we're done with that, and maybe we write the plus c from this guy is like being the plus c for all of them, okay? Yeah, but yeah, we said that this here is asking, and we said that in the basic practice video, we said that this is asking, what did we take the derivative of to get this? And so we took the derivative of natural log of x to get 1 over x. So the antiderivative of 1 over x dx is natural log of x. Okay, now the rest of them we have to work through, but yeah, that's just power rule, right? Like backwards. And by power rule backwards, I mean, like, you know, what we did in the basic practice video, and was showing that like the antiderivative of x to the n dx is equal to x to the n plus 1 over n plus 1, and then plus c if it were alone, which is if it were just one antiderivative by itself. But yeah, like I already have that plus c right there. But yeah, this is what we said. And therefore, using this, we see that this guy here is going to be plus 3, and then it's going to be x squared over 2. I went through these details much more carefully in the basic practice, so I'm not going to do that here. And then minus, similarly using this on this guy, we see that it's going to be x to the positive 1/2 divided by 1/2, which is the same as multiplying by 2, and then we have plus 2 times, and this antiderivative is just 1 dx, and a constant times dx has antiderivative that constant times x. So the antiderivative of 1 dx is just x, and so we have from the 2 in front of the antiderivative symbol, yeah, we have 2x. And yeah, you know, this is the antiderivative of 2x, or the derivative of 2x is 2. And so like if I wanted, I could put this 2 in there, and so that that's one way to think about it, right? But okay. And then we have plus the natural log of x, and then plus c. Okay, now what else do I have to do? Well, I could write this as square root of x, and that's about the only thing to simplify. The other guys are not like terms. I can't combine any of them, right? Like I can't add these two things or subtract them or whatever. And yeah, and there's no other x squared term, and this is 3/2 x squared. Yeah, so there's nothing else I could really do here, so we're done. And so let's move on to the second practice problem. Yeah, okay, cool. So the second practice problem, again using the sum and difference rule, I could write to start as being like, and the constant rule, I could take out the constant in front of the antiderivative or integral, and so I write this e to the x dx, right? And then we go minus, notice that 2 over x squared plus 1 is like 2, it's like 2 times 1 over 1 plus x squared, right? So I prefer to view it through this lens, right? And so first it means that I could take out the constant 2 and write it in front of my antiderivative symbol, right? So I do that, so I write my 2, and then what I have left is going to be 1 over, yes, it's x squared plus 1, but I prefer to write it as 1 plus x squared so that it's easy for you to recognize this as being the derivative of something familiar. I'll clue you in. It's an inverse trig function. And yes, this f of 0 is equal to 3 is assuming that the antiderivative of this is the function f, right? Like assuming that the antiderivative of these guys, well, all of this, that antiderivative, assuming that we know that it's called f of x, we know that the value of that antiderivative, the antiderivative of this guy, its value at 0 is 3. And so what that's going to allow us to do is determine the c, the plus c. Instead of just writing a generic unknown constant plus c, we'll be able to know what c is based on this information about the antiderivative of this here, right? So we know a little bit more about the antiderivative other than being able to find it like with a plus c. We could actually specify what that constant is. Okay, cool. And so that's what this information is going to help us do. But first, let's finish the job of finding that antiderivative, which is called f, right? Okay, and well, in this case, it is called f because of this information telling us that it's called f. Okay, so now, what did we take the derivative of? What did we take the derivative of to get e to the x? Well, e to the x. So I have 5 e to the x, and then I have minus 2. What did I take the derivative of to get 1 over 1 plus x squared? Yes, arc tan x, or tan inverse x. So here I have tan inverse, that a is ugly, sorry. Tan inverse of x, and then plus c. But as I said, we're going to be able to figure out what this unknown constant is based on this information, because supposedly this is equal to the function f of x. And we know that f of 0 is 3, so we know that 3 is equal to f of 0. But f of 0 is like plugging in 0 into this stuff. And so instead of f of 0, I'll just plug in 0 into this stuff. So that's 5e to the 0 and 5e to the 0, right? And then minus 2 times tan inverse of 0, right? And then plus c. Now, you should know tan inverse of 0 is 0. So 2 times tan inverse of 0 is 0. So this is 0. And otherwise, we have 3 is equal to 5. E to the 0 is 1. So 5 minus 0 plus c. So 5 plus c. And so then it must mean that c is equal to negative 2. So now we know what f is up to that unknown constant. We know it now. It's equal to negative 2. So instead of plus c here, we're going to write minus 2. Yeah? Okay, cool. All right. And so then these guys will set us up nicely to the end. And yeah. Okay, cool. So what does this say? This says find f of x given that f double prime is equal to 8x cubed plus 5. So since we know f double prime is 8x cubed plus 5, by finding the antiderivative of f double prime, we can hope to get to f prime plus a constant, right? And since we know something about f prime, we're going to be able to figure out what this constant is. So then we'll know f prime with the constant, and then we could integrate that, right? Like we could integrate f prime with its specific constant, and by integrate, I mean find the antiderivative. I mentioned in the basic practice video that integration, which is anti-differentiation, is the same thing, right? Okay. So by doing this, then I could get to f of x. Yeah. Okay. So, and then I could get to f of x plus c, right? But I know the constant that comes with f, because the specific f, because I have f of 0 is 1. So I have information to help me determine what this c is. And this c is not necessarily the same as that. Yes, and like some infinite coincidence, they could be like the same number, but like no. Okay, so I've laid out the I've laid out the basic plan. And by the way, because like this last problem is like very similar to this third problem, I'm gonna finish with the third problem, and I'm gonna leave it to you to figure out what this last problem is. Or if you like got something to do, then you don't like have to even bother. But yeah, let's find the antiderivative of f double prime, which is 8x cubed plus 5x, 5, just 5, not 5x. So this dx, we know, whether or not I write those parentheses does not matter. We know dx multiplies everything in front of it. Yeah, this we know is going to be, well, we know we could take out the 8, so it's 8, and then with the x cubed, we add 1 to the power, so that's 4, and then divide by this n plus 1. And I'm just using that rule, so that's divided by 4, and then we've got plus 5 times x, right? So we do that. And so then that means that now I could do this, right? And then write 2. Yeah, and of course I forgot my plus c, and so we write plus c. So this here is f prime. This is f prime of x. With any constant, f prime would have f double prime being this for any constant, but we know the specific f prime we're after because this information is going to get us the plus c. So it's going to pin down the specific f prime, but any variation of f prime with any constant here, like, and that's the variation, is this constant. So like changing this constant to anything will still have f double prime be this. But with this added information, we can pin down the specific f prime that gets us this antiderivative. Okay. So enough said. So f prime of x is equal to, now we have 2x to the 4th plus 5x plus c. And so using this information that we know, which is f prime of 1 is 8, we write that 8 is equal to f prime of 1, meaning plug in 1 everywhere I see an x here. So that's 2 times 1 to the 4th is 2 plus 5 and then plus c. So we see that the right hand side is 1 shy of 8. So that, but you get it. Well, yeah. C is 1 basically. you could do that arithmetic pretty easily. So with C being 1, then it means that I could get rid of this stuff. I know that the specific f prime is with this guy being 1, and now I'm going to take the antiderivative of f prime here to get to f. And yes, f would have not been determined specifically. It would have had to come with a plus c. But we have information about f to help us pin down that c. And so then here we are. And so I'm going to take the antiderivative of f prime to get to f, right? Well, you know that. So I don't need to write what I just wrote. I could just get to it. So 2x to the 4th plus 5x plus 1 dx, right? Okay, and this is going to get me f of x plus c, right? Okay, and I can determine the specific c. Well, it's going to get me f of x, and the left side is going to be like, yeah, it's going to be some polynomial with plus c, and that's f of x, but that's generic f. You get. So that means that, like, yeah, like if we use the power rule, you get x to the 5th over 5, right? Okay, and then plus 5x squared over 2, and then plus x, and then plus c, right? And this is supposedly f of x, right? And now there isn't really much cleanup to do here or here, so we're on to using this last piece of information. We know -1 is equal to f of 0. So f of 0 is like that, which is like plug in 0 for all these x's. So that's basically saying 0 plus 0 plus 0 plus c. So c is -1. So that means that I could write, instead of that, I could write a -1 right here, and then could be done. So we've determined this specific f. We found f of x, yeah? Okay, cool. All right, like I said, this last practice problem is like, only different from this previous one in the function f double prime is we're using is like involving trig functions. But yeah, like that's about it. And you could practice with that on your own and leave me questions if you have any questions in the comments section. All right, I hope this was helpful, and keep watching. Take care.